Right. So there's various different, we can customize our plots in various different ways. So if you look at the documentation of plot, you can see then we can create line plots, which we've done before here, which is the default. We can create scatter blocks, hex bin plots, and so on and so forth. So for instance, if you don't want to create a line plot like here, so that's a bit problematic because it doesn't really make sense to connect one start station with the next start station because they're not really, I mean, these trips, these are two separate trips. Really, there should be a start station going to the end station and this start station going to this end station rather than connecting them along the x-axis. So then it makes more sense to use a bar chart like this one. So I just use the same plot command, but now have kind equals bar. And now you see the plot is like where you have the start station in blue and then the end station in orange here for each trip separately. So in some way that makes more sense, even though of course we still have this abstract identifier of the station here on the left. And then you have a histogram plot, which essentially shows you how often certain stations were used. And so now here on the left you have the frequency, how often something occurred, and here on the right you have the stations. So you can see that, well, I mean the stations between 190 and 200 have been used massively, while the ones between, maybe these are kind of from 300 to 310 have been used not so much. Maybe these are kind of the newer ones. So then after we've loaded in the data, selected the parts that we're interested in, maybe cleaned up the data, then often it's useful to save the data again. And just like the read CSV, there's also a to CSV that you can apply to data frames. And then essentially it just spits out a string that contains the comma-separated form of your data. And you can load it up in another program. One thing that is quite useful is if you're doing data analysis as part of your master thesis and you write your master thesis in LaTeX or your bachelor thesis, then you can actually automatically generate LaTeX tables from Panda tables. And so you've done all your analysis, you've extracted the statistics that you're interested in, and then you can use the command to LaTeX to convert a data frame into a LaTeX file. And you can write it out and import it into your bachelor thesis. Which is really useful if you rerun maybe you've changed some of your input data, then you just run the entire Python program, it generates the new LaTeX tables, you compile your bachelor thesis, and then you've got the updated version. So now we can do some initial analysis on the data that we have. For instance, we could ask the question, which ones are the top 10 most used bike stations in Oslo? And the way you can do that is, what we need to do is, right, we have the trips, each row consists of a trip, and each row has a specific start station. And so what we want to do now is we want to count, for each station, we want to count how often a trip occurred. And the way you do that is you extract a specific column that you're interested in. In this case, it's our start station column, because that's where we want to count how often it occurred in the trips, how often it occurs. And then we call this function value counts. So bikes that start station gives us one series consisting of the identifiers of each item is one trip, and it always tells us the station that would use to start this trip. And value counts now simply counts how often that start station occurred in that series. And then we plot the top 10 one here. So what you now get is the first item The first row here tells us the station ID, so station 233 was used 7,832 times in October. Station number 267 was used 6,713 times, and so on and so forth. So now we can plot the results, and I use a bar plot for that. And here you see the result. So on the x-axis, these are the station IDs. On the y-axis, you see how often that station was used in October. So you can see there's kind of 3 stations that have been heavily used, almost twice as much as the remaining ones. So up to almost 8,000, and then very quickly drops down. And there's been a lot of stations that have been used quite extensively. It'll be interesting to see. Let's look at the last ones. Let's look at the 50 last ones. Yeah, so it kind of drops down, and there's been one that has been used only a few times. Maybe that was just installed here. Number 25036. Yeah, we can look at this later to actually find out which station that was. Let's look at the last 10. Oops. Oh yeah, no, sorry. I wanted to do minus 10 here. No. Minus 10 to the end. Here we go. So the 256 was only used 100 times. Maybe that was newly installed in October 2016. Right. So the next thing we want to do is, currently we only have data for October, but it would be useful to also have data for the other months. So we need to concatenate data frames. So we can just double check that we indeed only have October data. So I extract the start time column and call the minimum function on it. And so that now only works because the start time has been identified as a date format. So now things like minimum and maximum actually make sense. So minimum gives me the smallest or the oldest date in that series. And it's the 1st of October 2016 at 4 o'clock. And then the max value is 2016, 31st of October at 11 o'clock. So indeed, so that data range that we've loaded so far only covers October. So now we can use the same function, the readCSV function, to load in the September data. I use the same separator and the parseDates functions. So we load that in, and it will take some time again because of the parsing. But once this is finished, we can use the pandas.concat function to concatenate 2 data frames. So I take the September data and I take the October data, which was this one here, and concatenate the 2. And so once we've done that, we can check again. So now our data frame is called bikestats.sepoct because it covers both, hopefully, so we can check that again. And so indeed, the smallest timestamp now starts at the 1st of September, and it goes all the way to 31st of October. So now we've extended the data set to 2 months. And of course, now we could do that for an entire year and so on. The next important thing is that really what's annoying right now is that we have these stations, and the station IDs are just these anonymous identifiers, 256. What does that mean? So it would be much more useful if we could have the actual station name and maybe even GPS information about that station and so on and so forth attached to each trip. And so luckily, we can download the Oslo Bicycle API also provides us a list of all the stations that are available. And I've downloaded that data. It's called stations.json. So now we don't have a comma-separated file, but we have a .json file. The JSON file is very similar to a Python dictionary. So I've I've printed that, I'm printing out that file here. So you can see we have a curly bracket. This is just that the data starts. And then we always have a value, a key value, and then, sorry, a key, and then values. So here we have a key called stations, and then we have a list. That's exactly the same syntax as in Python. We have a list, and the list consists now of one station after the other. So here, the first item in the list is again consists of a dictionary. The dictionary has an identifier, which is 157, which is the identifier for that specific station. Then we get information about if that station is currently in service or not. So it might be maybe on repair or something. Then we have a title, Nylandsveien, so this represents where that station is. So the more specific subtitle to specify more in detail where that station is. We get information about the number of logs that that station has. And we also get the latitude and longitude, so the GPS coordinate for that station. And some additional bounds. So these should be, I guess, 4 values or 5 values representing a rectangle or something like that around that station. And so then if you go scroll down, then we have the next station. So now we have 158, in service 2, and so on and so forth. Right? And so that's a long list containing all the different stations. So we need to read this data in. The most obvious thing that we could imagine is that we use the pandas.readJSON command with the file name. Unfortunately, that doesn't work because readJSON expects the data to be in a very specific Pandas compatible format. So unfortunately in this case we can't use that. So what I had to do is I used an external module, Python module called JSON to import the data. So the JSON module has this function load that takes in a file name, which I provided here. And so after doing that, I was able to successfully load in that file. And you can see it's essentially exactly the same, but now we have Python dictionaries and Python lists here. But otherwise it's the same. We still have a list of stations. Each station consists of a bunch of attributes like bounds, ID, in service, number of logs, and so forth, and so on and so forth. So that's good. So the first thing that we need to, in order to get the information that we want, everything is contained in a big, it's a dictionary with an entry stations. So I'm actually only interested in the list of stations. So what I do is I just extract the keyword stations here. So that's just tidying up data. So now I have a list of stations with all the attributes. There's nothing important going on. But once I have that, I now can use another Python function that I had to look up. So it's called Pandas IO JSON normalize, that you can provide a list. And if you do that, we arrive at the data frame that we're interested in. So now I have one big data frame where each row represents a single station. For each station, I have latitude, longitude, ID, in service, number of logs, subtitle, and title. So this is all the information that is relevant for us. So then one thing that is a bit unnecessary here is that we have, so each data frame already has an index, and by default it just starts indexing at 0, 1, 2, 3, 4, and so on. But in our data, we also have an identifier, ID, which is the actual ID of the station. So it would make sense to use this identifier here directly as the index of the data frame. And we can do that by setting the index. So if you have a data frame and you call the function setIndex and you provide the column name that should be the new index, then what happens, wait, I should load the, no. Okay, I need to run this stuff first. There we go. There we go. Okay, then we load it in. So now we set the index. And now what happened is that the column ID has disappeared from the actual data frame, but instead now the data frame identifier uses the station IDs as an index. And so now instead of starting from 0, we start directly at the ID of that state of the first station, which was 157. And the reason why this is quite convenient is because, for instance, if we now plot the number of logs for the stations as a bar chart, so now automatically the x-axis will be the identifier. So here we now have the station IDs rather than the automatically generated data IDs. So these are the number of logs for the first 10 stations. So still, it would be, in our data, we have quite a lot of columns that we're not interested in. So the bounds, for instance, we don't really need, and the in-service maybe we're not interested in the subtitle. So it's often useful to tidy up a little bit and remove data that we don't need. The way you do that is you use the top function, and top just takes a list of columns that you want to top, and then you need to set axis equals 1. So axis equals 1 means you want to remove columns. If you set axis equals 0, you would remove rows. But in this case, we want to keep all the stations. So then I drop the bounds. Oops. Sorry. Okay, what am I now? There. So I want to drop bounds and subtitle just to clean up a little bit, and I end up with a bit cleaner station data frame. Okay. So then I already showed you this log function to extract only specific parts of the data frame. I'll just jump over that. So here's the syntax if you want to extract from item 160 to 170, only center latitude and center longitude. So then you get this subset of a data frame. One thing that's quite useful, again, is that we can use mathematical functions on data frames. So if you're interested in this number of logs and we want to compute some statistics, we can ask for the minimum number of logs, we can ask for the maximum number of logs, and we can ask for the mean number of logs. And we find out that the smallest station is 6 logs, the largest station is 48 logs, and the mean value is 22 logs. We can also extract all the rows that are somewhat large stations. So here I use the data frame, and then I have a condition here in the selection. So I say I'm looking for all the stations where station's number of logs is larger than 30. So if you do that, and you look at the results, you see now that we have a data frame that only consists of the stations that have at least 30 number of logs. So all of these are above 30. And then we can, of course, compare how many large stations do we have compared to how many small stations. And so 20 of all the stations, 20 out of 130 stations have at least 30 logs. So the next thing, it would be useful to be able to plot the position of the logs. And we have the GPS coordinates, the latitude and the longitude. And I used an external package called GM Plot to plot that. And I won't go into detail here, but essentially what you provided, I just jump over this. But what I do is I extract the latitude and longitude for all stations, and then extract their raw values, so it's numpy arrays. And so here, for instance, I have the latitude values for each station as a long list as a numpy array. And so then you can do this. Here I used Google Maps, and it was all a bit messy, but at the end it worked. And if you do this nicely, you can save it as an HTML file, and then you can open that file in Google Maps, and you get an overview of all the stations. And yeah, I didn't save them. Oh, maybe I did. No. Okay, so here you see all the stations plotted around Oslo, and that was from 2016. So I'm sure there's more. So what I wanted to show you is that in principle, right, you can use other visualizations than the ones that are in PyPlot. So for instance, often it's useful to use some kind of mapping. Okay, so now we've loaded in the stations. So we've loaded on all the trips, we've loaded in all the stations. The next thing is to merge the two. So still currently, if you look at our trip statistics, we have these start stations just as identifiers. But really what I would like to have is I would like to have another column here where it says start station name, and then the name of the start station, and start station end station name, and then the end of the end station. And maybe even the GPS coordinates that I can draw GPS lines for each trip. And so the important command, so what we need to do is we have two different data frames, one containing the trips, one containing the stations, and now we need to merge the two. And there's a command called pd.merge that does exactly that. And so if you're familiar with databases, then specifically SQL databases, then this will now be familiar with you. But I'll explain it now. So this merge command takes in one data frame on the left and one data frame on the right, and the output will be a merged data frame that contains the data of both data frames. So it's going to be larger, an extended data frame. And in order to do this merging, this merge command will look up matching values in the left data frame and on the right data frame. And in our case, these matching values will need to be the start station ID in the trips and the index in the station data frame. Right? So we want to match the start station ID here with the relevant station in the station data frame. And then there's a question on there's also a command on how you merge these two data frames. And there's essentially 4 different choices. There's something called, you can merge them in an inner way, you can merge them fully, left and right. And I want to demonstrate how that works on a very simple example. It's much easier to understand this on just a tiny example. So what I've done is I've created a data frame. It's essentially just a simplified version of what we already have. So I create one data frame that consists of station ID and a name. So we always have ID, name, ID, name, ID, name. In this case, we only have 3 stations, 5, 6, and 7. And then I also created a trips data frame that consists of just a station ID. In this case, I only have start station ID, and then the start time when the trip started. So here I have 3 trips, starting from 6, 5, and 8 with different start times. Okay. Now, the interesting part here is that there's one station, station number 7, that never appears in a trip. So station number 7 is never used to start a trip. But for some, maybe this is a mistake, but there's a trip that started from station 8, which is not part in the station list. Right? So we have, in some way, we can match. So the first trip here starts at station 6, and that I can match up with the Faulkner station up here. And then the second trip starts at station number 5, which I can map up with the Opsal trip here, the station here. But the last one here I can't match up. So now let's call the merge command on these two. So I call pd.merge. So what do I want to merge? I want to merge my trips with my stations. These are the two data frames. Then I need to specify, I just jump over this for now. I need to specify how the rows should be matched up. And so on the left side, which is the my trips data frame, I want to use the start station ID. Right? So this is the column that I want to use for a key to match each row. And on the right data frame, which is my stations here, I want to use station ID, right, which is this one. So I select the two columns where I want to match the identifiers. And now it's the question. So if I do this, wait, I need to execute these. Okay. So now if I do that and I use, okay, so first of all, what do I get if I run this? I get a new data frame consisting of start station ID, which was this column, start time, which was again from the trips column, and then I have all the columns from the right data frame, namely station ID and name, station ID and name. So now we've merged these two data frames, right? We've got all columns, and you can see that the start station ID and the station ID is always matched up. So here I have a 6 and here I have a 6. And here I have a 5, and here I also have a 5. So that's exactly how it worked. Now, what's interesting is that the trip where there was no station ID, the last one here, doesn't show up in the result. Also, the station number 7 that was never used in the trip also doesn't show up here. And that's because I set how equals inner. So inner only returns results where you have matching values from both the left and the right. The opposite of inner is outer. If I use outer, if you use outer, you always get the results of, you will always get all the rows from my stations and my trips. Right, so here you get all the results, even for the station where it never had a trip. And in that case, the values are just filled up with not a number. So it just fills out missing values with nans. And then what I can also do is I can say left. And so when I say left, then the result will be, I will ensure that I always get the results of the left data frame. In this case, it would be my trips. So in this case, I have always all the values of my trips, including the number 8, where I didn't have a starting point, a starting station. But I potentially lose some data on the station. So the station number 7, which was never used, does not show up here in the result list. And then finally, you can use right, which is the opposite. So now I have Meierstuhlen, which was never used in a trip, but this trip number, starting in number 8, doesn't show up here. Okay? So now let's go back to our bicycle example. So what do we have? We have the bike stats have start station and end stations, and our stations table has, well, that's actually the index that we want to match up, because the index contains the station ID. So the big command that we need to run is pd.merge bike steps sept oct, right? So these are our trips. We want to match that up with the stations. And I use how equals left because I want to make sure that the results definitely contains all the trips. Potentially, I might not have a matching stations and I will see some nans, but I want to make sure that I keep all the trips. And then I need to specify how I want to match the data. So I say on the trips data frame, I want to use the column start station. And on the stations data frame, I use this command write index equals true, which means it should match up with the index of that data frame. And the result is the following. We have now an extended trip data frame consisting of all the columns that we had originally in our trips data frame, so start station, start time, end station, end time. But now we have also all the information about the start station, so including latitude, longitude, and the title. So then we can make sure that we didn't lose any data. So here I'm just comparing how many trips we had of the merged, before the merge and after the merge. And they're exactly the same number of trips. So that's fine, we haven't lost anything. And now we can do a second merge, where we merge the information about the end station. So I use the same command again, pd merge. Again, I want to merge with the stations. Again, I want to keep all the trips. But this time, I want to match with end station. I want to match the end station with the index of the station's data frame. And then I also use some suffixes to be able to, because now number of logs will be, and the title of the stations will be there twice, right? It will be there from the start station and from the end station. So I use some suffixes to separate the two. But now, after all this, we have an even bigger table that consists of every trip, the start and end time information about every trip, and the station title of the starting point, and the station title of the end point. And so now, right. So now we can ask again the question about what is the busiest station. But this time we can actually extract the names of the busiest stations. So I use the same trick as before. I call this value, I extract the start station IDs, and I count how often that station occurs. And so still, I get now that station number 233 was used 19,000 times, and station number 267 was used 17,000 times. But now I can use this. Now I can use this information here in the log function, so to extract the full data frames for all these indices. So I'm interested in all these stations here that occur in the index, and I want to show their full information. So I write stations.log, and then please show me the information for all the indices that I've extracted here. And that's the result here. So number 233, which was used 19,000 times, was the station in Alexander Schillerns Platz. And then the second busiest stations, which was 17,000 times, was Bislett Stadion and Olaf Rues Platz, and so on. And so it's interesting, right? So the busiest station here in Alexander-Schillensplatz only has 25 locks. So it's quite a small station for being the largest, the most busiest station. So it'll be interesting to see if they might have upgraded that by now, because I expect Olaf Ruhes here is a fairly large one. So interestingly, these ones are much bigger than the top ones. So then it's also interesting to see what is the usage pattern of these busiest stations. Maybe you can figure something out if they're used more as in the morning or in the evening, or maybe during the day mostly of tourists. So the way we do that is we extract. So what I want to create now, I want to create kind of a plot with maybe one day. And I want to show how busy that station was during the day. So the first thing that I do is I extract all the trips that started at Alexander-Schillensplatz. So what I do is I use this bracket notation with a condition inside, where I say I'm only interested in the trips where the start station equals busy station index 0, which is the most busy station. So then showing the top 5 results is that here you see all the trips. And you can also see that the start title or the start station is always Alexander-Schillensplatz. So we selected the trips, only the trips that started from that station. So now I want to create some statistics about the usage. And at the moment, so what I need to do now is I need to kind of resample the data. Right? So what I want, for instance, I want to compute on average how many times per hour was that station used. So rather than showing each individual trip, I now need to create an hourly statistic of that station. And the way I do that is I create a new data frame that has just one column, namely just a counter, and I just set that counter to 1. And that counter is supposed to count the number of trips at that point in time. And then as index, I use for the data frame, I use the start time. So the resulting data frame is the following. So for each trip, I have the exact time here, which is 4 o'clock, 11 minutes and 8 seconds. And at that time, there was 1 trip. And the next trip was 6 minutes later, another 1 trip, and so on and so forth. Okay, so that's quite simple so far. But now we can use a function called resample. And resample now creates average statistics about that column. And what I do is I take this data frame and I say dot resample 30 minutes. So this 30t means resample that time series into blocks of 30 minutes and sum up the results in between. So once you've done this now on the time series axis, now instead of having the exact times, we only have one time every 30 minutes. And the counter column now counts how often how many trips we had within these 30 minutes. So now we're much closer to what we want, right? So we start off with 6 trips in the morning, and then it goes to 9, then it goes to 9 again, and then to 26, and then to 7 again, and so on and so forth. And so this we can now plot. So I can write resample trips, and I locate, here I limit the data to 1 day, or actually multiple days here. I say 1st of September to 3rd of September from 4 o'clock to 4 o'clock. And you're supposed to plot the counter column. Yeah. And that's what you get. So this is the plot here. On the x-axis we have the 3 days, or the 2 days. And you see the usage pattern. So you start off fairly low in the morning, and then there's some peaks here. Actually, it's fairly frequent until in the evening where it drops down. This is between, there's some time shift here, but it's supposed to be in between 0 and 6 in the morning. There's no trips at all, and then it peaks again. And so one thing that's quite interesting is that you see these kind of 2 peaks here. There seems to be one peak here, and then a very high peak again. And the next day we see the same peak. So you can see if that actually repeats. So let's try 3rd to 5th. Oops. Oh no. I haven't executed all this stuff. Let's try. No. How far do I need to go back? Oh, that looks very different. Okay. Oh, maybe. Oh, there was a party going on. 35. Okay, let's try 6 to 9. Oh, maybe that was a weekend. Yeah. Huh. Yeah, okay. Well, you can see you can play around with the data and find some more stuff. Any questions regarding pandas and data analysis? No? Okay, then see you next week.